Alright, now I will go through and do some of the homework problems with you. These should be pretty quick. Alright. Typically I'll just make something like this for each assignment. I'm not going to go over every question because I want you to do some on your own. So name 4 points. Remember, in this diagram, S is not a point. This is plane S. This is plane T. So you can use any of these 5 points to answer that question. Name 2 lines. Line BC, line CB, same thing. Line BC, if I wrote line BC and line CB, those are not 2 lines. It's 2 different names for 1 line. Alright, so that would not be an appropriate answer for that one. You'd have to name the other line for that. Name the plane that contains A, B, and C. We could call it plane S, or you could use 3 letters. Alright, moving on. Another same diagram. Remember, V is not a point, and this little lowercase f here is for this line F. We could call this line F, and this lowercase g, we call this line G. There's no point G here. There's a line G. This is lowercase g. It says give 2 other names for line WQ. You can call it line QW, or you can call it line G. And you have to spell out line G. Give another name for plane V. You should have to use 3 points. You can't use R, Q, and S, because R, Q, and S are collinear. So you got to use like R, T, and S. Alright. Name a point that is not coplanar or non-coplanar with R, S, and T. So any point that's not on plane V, like W. Like I said, I don't want to do all the problems for you. I need you to think through some of these. Here we have diagram. And if you look here, this is segment BD. Alright. So up here, it's hard to see, but this is line WQ. The formatting is a little off. And this is segment BD. So segment BD is the same as segment DB. Alright. Look at here. Even though it doesn't show up very well, this is ray AE. What is another name for ray AE? Interesting. So ray AE starts at A and goes through point E. And it goes forever in this direction. Is there another ray that starts at A and goes forever in this direction? Because remember, this keeps going. So these ray AE is the same as ray AC. Opposite rays. So now let's do this one. Starting there and going in opposite directions. So we could say ray EB, and starting at E again. Which is the opposite direction of B? That'd be ray ED. Notice again, they have the same endpoint. Over here, describe and correct the error. AD, so starting at A and going through D, is an opposite ray with AC. Do they go in opposite directions? No. It'd be ray AB. So it's not AC, it's ray AB. Alright. Moving on to the back page here. We've got the cube like there was in the notes. Let's just go through. Name a point that is collinear with E and H. So E and H, J would be on that line right there. Name a point that is coplanar with D, A, and B. So again, D, A, and B are making this top, the top of this. It's representing the top of this. So any of these points, I or C, would be an answer to that. Name the intersection of a plane. The answer is always a line. If I'm asking you to name the intersection of a plane, it's always going to be a line. So let's see which planes we're trying to intersect here. Planes BGH, BGF. BGF. That's the back plane, and plane HDG. That's the side plane. So where's the back plane intersecting the side plane? It's right here. Right here. So that's line CG. Okay. More cube stuff. Name all points that are not coplanar with the given point. So for example, P, Q, and R. P, Q, and R. That's the bottom surface. So the answer would be N, K, L, and M. Those are not coplanar. So it's anything that's not on the bottom. Let's go down to 44. What about plane Q, K, L? Now this one's shooting through, and it goes through P actually. It's shooting through the center. Can you see it? So what points are not on this plane that's shooting through the middle? It'd be N, M, and R is behind it. So N, M, R, and S. Critical thinking. Given 2 points on a line and a third point that is not on the line, it's possible to draw a plane that includes the line and the third point. Sure. Given 2 points on a line and a point not on the line, there could be a plane that has that in it. Sure. Yes. Is it possible for 1 point to be in 2 different planes? Well, look at the diagram up here to help you. There's, like, M is on the top plane, on the front plane, and in the side plane. So think about that. Next, explain why a 4-legged chair may rock from side to side even if the floor is level. So, wow. Okay, how am I going to draw this? Let's say here's the floor. And you got a 4-legged chair. Wow, this is a bad chair. Okay? Is it possible that one of these legs is just a little short? What would happen if one of these legs was short? It would wobble back and forth. You ever been in a desk that wobbles? But what if I eliminated that leg? Would a 3-legged chair ever wobble? No. Because what's true about 3 points? 3 points will always be on a plane together. 3 points always make a plane. If you add the 4th leg, now you might wobble. Alright? But if you make that 4th leg perfect, you might not wobble. But if that 4th leg is just a little off, maybe it's a little long, maybe it's a little short, there'll be a little bit of wobble in that. Alright, last thing. Complete the statement with always, sometimes, never. I love these types of questions. A line. Does a line have endpoints? Never. A line goes forever. A segment has endpoints, but a line does not have endpoints. A line and a point, sometimes. That line and point do not intersect. This line and this point do intersect. A plane and a point, same idea. You could have a point above a plane, you have a point on a plane. Two planes sometimes intersect, right? These planes do not intersect, these planes do intersect, and these planes do intersect, and these planes intersect, and these planes intersect. Okay, so it's sometimes. 2 points always determine a line, right? Isn't that what we said here? Through any 2 points, there is exactly one line. Any 3 points determine a plane. Can a spider use any 3 points to make a spider web? Can a spider use these 3 points to make a spider web? No. Can a spider use these 3 points to make a spider web? Sure. What's the difference? These 3 points are collinear, and these 3 points are non-collinear. So any 3 points sometimes determine plane. Look at this. Any 3 points, and now there's not on the same line, so this changes it now. This changes it to always. Any 3 points not on the same line, always make a plane. And lastly, 2 lines that are not parallel intersect. These are parallel lines. Will they ever intersect? No. These lines intersect. What about these lines? It's hard to show this. These lines are not parallel. However, they don't intersect. Now they're intersecting, and now they're not. It's actually sometimes. This is a tough one. Alright, so ideally you did the homework first by yourself, and then you watch this video to help you. Now you need to just take a snapshot of your assignment. Make sure that you put your name on the top. Put the date, put your block, submit it. And that is that.